Now we want to look at writing equations of hyperbolas given various characteristics. We're going to look at what happens if the characteristics we're given involve the transverse axis or the conjugate axis, the vertices, or the foci. I have the two equations here for hyperbolas. Remember, since hyperbolas involve subtracting, the order is going to matter, whereas with ellipses, order did not matter because we were adding. So we always just said, well, a squared is always going to be the bigger one, whether it's in the front or the back. With hyperbolas, we are always going to say a squared comes first. It's always going to be alphabetical. So if the x squared is over the a squared, the x squared is coming first, remember then your hyperbola is going to open something like this. So almost kind of opposite with what you would expect if you think about the way our parabolas open. If the y squared is coming first and above the a squared, then it's going to open something more like this. Also remember that in order to write an equation for a hyperbola, just like an ellipse, we're going to need our center, hk, and we're going to need to know what a squared and b squared are. If you aren't given enough information to determine what a squared and b squared are, you can always use the relationship between a, b, and c that I have listed here to find that. It's very similar to an ellipse, except now we're adding, mainly because our c, our foci, are going to be inside of our ellipse, which are going to put them farther from the center, or excuse me, inside of our hyperbolas, which are going to push them farther from the center. So that is going to be a longer distance for C. The vertices, remember, are going to be these points here. So let's look at the first example. And we are told some information about the vertices as well as our foci. So as usual, I'm going to go ahead and sketch this graph. So I'm not going to be real exact. I'm just going to know that I'm going to go back 3 and down 6 and then back 3 and up 2. So something like this. Okay, well now I know that since these are my vertices, that this is going to be opening like this, which tells me I'm going to have y on top. So I'm going to have y minus k squared over a squared minus x minus h squared over b squared equals 1. So now I'm going to set about finding that information that I need. So first thing I'm going to look for is I'm going to look for my center. My center is going to fall in the middle of my two vertices. It will line up with the vertices, so I know my h value is going to be -3. To find my k value, I'm going to know that my k is going to be the middle or the midpoint of -6 and 2. So I'm going to go ahead and use my midpoint formula. Remember, that's just an average. 2 plus -6 over 2. It's going to be -4 over 2 or -2. So now I know my hk. I can also find my a because remember a is going to be the distance between my center and my vertices. So I can find the distance if I use a distance formula. So a distance formula is just going to be absolute value of one minus the other. So I'm going to go ahead and say my a is the absolute value of 2 minus a -2, giving me an a value of 4. And now I need to also find my b value. But I notice I'm not given enough information to find my b value. The only other piece of information that I'm given that I haven't used yet are my foci. My foci I have at -3, 3, and -3, -7. So remember that my c is going to be my distance from my center to my foci, just like it was with the ellipse. So if I could figure out my c value, I could use a and c in this relationship here to assist me in finding out what my b or my b squared is. So c is going to, once again, be the distance between the center and my foci. So I'm going to go ahead and say that's c, and I'm going to use the same distance formula as I did up above. So I'm going to go ahead and say 3 minus a -2. Absolute value of that ends up being, I have a c value of 5. So I can go ahead and say that a squared plus b squared equals c squared. So I get 16 plus b squared equals c squared. So I subtract 16 from both sides, giving me a b squared value of 9. So now that I know what a, and therefore I could find a squared, I know b squared, and I know h and k, I can go ahead and just write my equation for my hyperbola. And I have y minus k, so plus 2 squared over a squared. Since a was 4, I'm going to go ahead and square that and get 16. And then I'm going to do minus x minus a minus 3 squared over my b squared equals 1. And there's my equation for my hyperbola. I do want to look at one more example. Okay. And in letter B, we're given a little bit different information than we were in letter A. You know, we're also still told our vertices, but we're also given information about our conjugate axis. Remember, that's our shorter axis. Well, let me rephrase that because it's not necessarily going to be our shorter axis. Remember, that's our axis that we determine from B. So essentially, our conjugate axis is always going to be a length of, 2B, which tells me that B must be 5. I'm also going to go ahead and plot my vertices. So I'm going to go forward 3 and up 2 and forward 3 and up 6. So my vertices are showing me that once again, I'm going to have y squared coming first. So there's a general form of my equation. I'll start by finding my center. It again is going to have a common h value. It lines up. I can find the midpoint. So 6, so let's see, k equals 6 plus 2 divided by 2. So I get 8 over 2 or 4. So once I have my hk value, I also have my b value. All I need to do is find my a value. Well, a, remember, is going to be the distance from your center to your vertice. So if I can find this distance here, how many units do I go to get from 4 to 6? I'll have my a. Well, I know to get from 4 to 6, I go a distance of 2 units. So I also know that a is 2. Since I have all my information, all I then need to do is plug it into my equation. Y minus 4 squared over a squared minus x minus h squared over b squared equals 1. And again, notice it's all about order with hyperbolas. It's not about which is bigger. So in the first example we looked at, notice that a was the bigger value, but in the second example, b was the bigger value. It's all about a coming first.